Good day everyone, my name is Rabac and today I will be solving open-ended problems and I will show you how to get its derivative and its simplified form. This is for the differential calculus. So we have here the number 1, f of x is equal to y square root of x plus 1 is equal to 4. We are going to get or solve its product rule. So we have here the y prime square root of x plus 1 plus y, the derivative of square root of x plus 1 is equal to 1 over 2 square root of x plus 1 is equal to 0. So next we are going to solve each y prime. So y prime square root of x plus 1 is equal to negative y over 2 square root of x plus 1. Since there is a common between the two, the square root of x plus 1, square root of x plus 1, we are going to solve for each, cancel out, and square root of x plus 1. The remaining of that is x plus 1. So our final answer for y prime is equal to negative y over 2 times x plus 1. So let's proceed with the number 2. Here the f of x is equal to 5x squared over x plus 47. We are going to solve each product rule. So v du minus u dv over v squared. So we have here f prime is equal to x plus 47. The derivative of du is 10x minus 5x squared times the derivative of this x plus 47 is 1 over the x plus 47 squared. So f prime x is equal to x plus 47 times 10x equal to 10x squared plus 470x minus 5x squared times 1 is equal to 5x squared over x plus 47 squared. Since there is a common 10x and negative 5x squared, we are going to solve for that and it results to 5x squared plus 470x over x plus 47 squared. So after that, since we can factor 5x squared plus 47 by its factorization of 5x. So we have here x plus 94 I mean, okay, and copy the x plus 47 squared. So this is our final answer for the number 1. This is our final answer. So let's proceed with the number 3. Okay, so our next problem is 2xy minus y squared is equal to 1. So we are going to use the steps of implicit differentiation. Okay. So number 3, f of x is equal to 2xy minus y squared is equal to 1. For the implicit differentiation, we have here another na-add na dy over dx. In this part, medyo kuan-kuaning malibog pero with practice problems na kuha rin tayo siya. So, we are going to get its 2y plus the 2 times the x and the equivalent of this y is 1. Since we are going to get its derivative or equivalent of y, we are going to add dy over dx. So, minus 2y. Since we are going to kuan siya pong the derivative of the y squared, we are going to add dy over dx. And it equals to 0 because 1 is a constant and the derivative of constant is 0. Next, we are going to from the left side, the part is dy over dx, and from the right side, we are going to transfer 2y. So we're going to copy 2x times 1, so 2x dy over dx minus 2y dy over dx is equal to, we're going to transfer this 2y to negative 2, 1. So in order to get is dy over dx, we are going to put here dy over dx is equal to, so wala na siya. So divide both sides by negative 2x minus 2y. So we have here negative 2y over 2x minus 2y. Since puro sila 2, we are going to cancel it out. Since if we are going to divide it both sides by 2, wala gyapon. So our final answer is y over 2 over x minus y. So this is our final answer. dy over dx equal to negative y over x minus y. Number 4, we have here the f of x is equal to sine x tan x. So by that given problem, we are going to apply product rule for that. So f of x is equal to, derivative of sine is cos x, copy tan, this is u, this is v, tan x. After that, we are going to add, copy sine x, and gets the derivative of tan x second squared x. So this is our final answer. So let's proceed with the number 5. Okay, so for the number 5, we have here the problem f of x is equal to sine x cubed cos x cubed. By that problem, we are going to solve its product rule. So udv plus vdu. So we have here f prime x is equal to, copy this, sine x cube and solve its cosine, gets its derivative. Okay, so let's proceed with sine x cube times negative sine x squared. Derivative of x squared is times 2x. And we are going to subtract it from this derivative of sine x squared is cos x cube times 3x squared, derivative of x to the third power, and copy cos x squared. So by getting its answer, we are going to apply the chain rule and substitute it. So isulat na to daan first ang cosine. So first this 3x squared, copy this cos x cubed, this 1 cos x squared minus 2x sine x cubed, continuation sine x squared. So this is our final answer. So let's proceed with the number 6. Number 6 problem is f of x is equal to a to the x over e to the x. So by this problem, we are going to rewrite it first. So rewrite it first to f of x is equal to a to the x, e to the negative x. So apply its product rule from this. Okay, so f prime is equal to, copy a to the x times e to the negative x plus e to the x e to the negative x times negative 1. So, and it equals to e to the x, ln a, okay, ln a times e to the negative x minus x, e to the negative x. So, we are going to factor it out since there is common e to the x. So, f prime x, so it equals to e to the x, e to the negative x times the ln a minus 1. Since there is a negative exponent, so we are to put it in the denominator. So e to the x over e to the x times the ln minus 1. So this is our final answer. Number 7. Number 7 problem is f of x is equal to ln 3 over x. So applying the rule of the logarithmic, okay? So we are going to distribute it first and subtract with how we are going to apply in getting its quotient or having a denominator. So f prime x is equal to ln 3 minus ln x. So f prime x, the derivative of this ln 3 is 0 since it is a constant, minus the derivative of ln x is 1 over x. Okay, so f prime x, 0 minus 1 over square, the remaining is negative 1 over x. So this is our final answer. So let's proceed with the number 8. We have here the problem 8. Y is equal to x to the 5th power tan x. So we are going to apply its product rule. Okay. So first, let us get the derivative of this x to the 5th power. So derivative of x to the 5th power is 5x to the 4th, copy tan x. Next, plus copy the x to the 5th, get the derivative of tan x. It is equal to secant squared x. So this is our final answer. So number 9. We have here the number 9. Y is equal to 2 minus x over 3x plus 1. So next, we are going to apply its quotient rule. So we all know the quotient rule is v du minus u dv over the v squared is equal to 3x plus 1, since the u and the v, times the derivative of this 2 minus x, negative 1, minus 2 minus x, derivative of this 3x plus 1 is 3. So multiplies by 3x plus 1 squared. So y prime is equal to distribute 3x plus 1 times negative 1 is equal to negative 3x minus 1. Negative 2 times 3 is negative 6 minus negative x times 3 plus 3x over 3x plus 1 squared. So y prime is equal to, cancelled out, negative 1 minus 6 equal to negative 7 over 3x plus 1 squared. So this is our final answer. Number 10. Here, the next problem, y is equal to square root of 3 minus 2x. Okay. So we are going to solve for number 10. We are going to solve its chain rule. And before we're going to proceed, let's rewrite first, since it has a square root sign. So 3 minus 2x, square root sign is 1/2. Apply the chain rule. Y prime is equal to 1/2. 1/2 times 3 minus 2x. So 1 half minus 1 is negative 1 half times the derivative of negative 2x is negative 2. Okay, so after that, we are going to multiply. Okay, so it results 1 half times negative 2 is negative 1. Since it is a negative exponent and we're going to copy it, let's move it for the denominator. So 3 minus 2x and 1 half. We can simply also just copy the square root since 3 minus 2x. So, it's up to you where asa ka comfortable. So number 11. Y is equal to 2 over 5x plus 1. So let's rewrite using a negative exponent since this is a whole number. So y equal to 2 times 5x plus 1. Since 3 is in the denominator, we are going to put it in the numerator. So we apply the chain rule for that. So y is equal to negative 3 times 2 times 5x plus 1. Negative 3 minus 1 is negative 4 times its derivative 5 is 5. Equal to negative 3 times 2 times 5. Okay, so it is negative 30. Since there is a negative exponent and we are going to just copy this, so let's put it in the denominator. So 5x plus 1 to the 4th power. So this is our final answer. So number 12. We have here the next problem. Y is equal to 2 square root of x minus 1 over 2 square root of x. So before we are going to apply its in getting its differentiation, we are going to rewrite with their exponents. So y is equal to 2x to the 1 half minus 1 half x to the negative 1 half. Okay, so we are going to differentiate term by term. So we have here y prime is equal to 2 times 1 half x to the negative 1 half minus negative 1 half times 1 half times x to the negative 3 over 2. From this term, 2 times 1 half x to the negative 1 half, we have here 1. So we copy x negative 1 negative 1 half minus. Okay, since we have here the sign negative times negative, it's already positive. So 1 half times 1 half is 1 half times 1 half is 1/4. Okay, so 1/4 copy x to negative 3. So we have here the negative exponent. So in order to make that negative exponent positive, so we're going to transfer it for the denominator. So write with radical. So 1 over x to the 1 half plus 1 over 4x to the 3 over 2. So this is our final answer. Let's proceed with the number 13. We have here y is equal to 3x 2/3 minus 4x 1/2 minus 2. In solving this number 13, we are going to differentiate first the each term, this, and this. So, y is equal to 3 times 2/3 by the using chain rule. Yes. Times 2/3, copy x, then 2/3 minus 1 is negative 1/3. Okay, so minus 1/2 times 4 x to the negative 1. So simplify it. 3 times 2 third x to the negative 1 third is 2x negative 1 third minus 1 half times 4 is 2 copy x to the negative 1 half. Since this is already whole number, we can make this negative exponent into positive. So y prime is equal to 2 over x 1 third minus 2 over x 1 half. So this is our final answer. So let's proceed with the number 14. Number 14, the problem is y is equal to root of x squared plus 2x minus 1. Okay, our number 13, by the way, guys. So we are going to rewrite it first. So x squared plus 2x minus 1 half. And next, let's apply its chain rule. So copy 1 half x squared plus 2x minus 1 half minus 1 is negative 1 half times derivative of x squared plus 2x plus 2. So we are going to multiply 1 half times 2x plus 2 results to x plus 1 over, since it is a negative exponent, so we are going to put it in the denominator. So x squared plus 2x minus 1 half. Okay. So next is number 15. Number 15, the problem is y is equal to x over square root of 1 minus x squared. And by that problem, the number 15, we are going to rewrite it first. So it equals to y is equal to x times 1 minus x squared negative 1 half, since it comes from the denominator. And let's apply its product rule. So we have here the y prime is equal to 1, since the derivative of x is 1, so 1 times 1 minus x squared negative 1 half plus x times negative 1 half. Next, let's apply from this to this video part. So 1 half times 1 minus x squared negative 3 over 2 times negative 2x. So next, we are going to simplify it. Simplify y prime is equal to 1 minus x squared to the negative 1 half plus x squared times 1 minus x squared negative 3 over 2. Factor 1 minus x squared, 1 minus x squared. So it results to y prime is equal to, how we are going to factor it out. Okay, so 1 minus x squared, copy 1 minus x squared. Okay, negative 3 over 2 times the 1 minus x squared plus x squared. So y prime is equal to 1 minus x squared negative 3 over 2. Since it is a negative exponent, so we're going to put it in the denominator. So y prime is equal to 1 over 1 minus x squared to the 3 over 2. This is our final answer for the number 15. Let's proceed with number 16. For the number 16, we have here y is equal to ln e to the x over e to the x minus 1. Okay, so by solving this number 16 problem, we are going to solve or get it logarithmic properties. So y is equal to ln e to the x minus ln e to the x minus 1. Okay, so y is equal to its derivative ln times e to the x minus ln e to the x minus 1. So we are going to differentiate it. So we have here the y prime 1. So the equivalent of x is 1. 1 minus e to the x. Since ln is 1 over x, or the u over x. E to the x over e to the x minus 1. Next, simplify it. So y prime is equal to negative e to the x minus 1 minus e to the x power is equal to e to the x of minus 1. So we are going to cancel this because e to the x minus is 0. So the remaining is negative 1 over e to the x minus 1. So this is the final answer. So number 17. We have here the problem ln secant x plus tan x. Okay. So y is equal to ln secant x plus tan x. So first, we are going to differentiate the u. Our u is this one. U. Okay. So by differentiating this u, we have here secant x is the derivative of that is secant x tan x. So differentiate it, secant x tan x plus the derivative of this tan x, or the differentiation of tan x is secant squared x over the secant x plus tan x. Next step is we can factor it out since there is a secant x and here is secant squared x. So it's ma-factor to siya by secant x times the tan x plus the secant x over secant x plus tan x. So cancel this. Our final answer is secant x. Number 18. We have here y is equal to tan negative 1 x over 2. Okay, so we are going to use the formula in getting the tan to the negative 1, the u prime over 1 plus u squared. So our u prime here is x over 2 and the derivative of the x over 2 is 1 half. Okay, so y prime is equal to 1 half over the 1 plus the u squared. So x over 2 squared. So simplify it. Y prime is equal to 1 half. 1 plus x over 2, the second power is x squared plus 4 over 4. So by solving this 1 half over x squared plus 4 over 4, it results to 2 over x squared plus 4. So this is our final answer for number 18. For number 19, we have here the given y is equal to x squared sine 1 over x. X is not equal to 0. So in number 19, we are going to solve its product rule and apply its chain rule. Okay? So the derivative of sine 1 over x is cos 1 over x. Okay? So derivative of x squared is 2x. So we are going to substitute it by using a product rule. 2x times sine 1 over x. To subtract it by copy x squared, the derivative of sine 1 over x is cos 1 over x times its 1 over x squared. So cancel this, and the remaining for this part is cos 1 over x. So we're going to copy 2x sine 1 over x minus cos 1 over x. And this is our final answer. For number 20. For number 20, we have here y is equal to ln x squared of x squared plus 1. By having that parenthesis, we are going to expand its logarithm. So, expand, so ln x plus ln square root of x squared plus 1. Okay, so extract this by the use of 1/2 and apply the rule of the chain rule. So 1/2 times ln x squared plus 1. After that, we are going to differentiate it. So the equivalent of ln x is 1 over x, okay, plus 1/2 times the 2x from this. Since the formula of ln is u prime over u, 2x over x squared plus 1. After that, y prime is equal to, copy the 1 over x plus 1/2 times 2x is x over x squared plus 1. After that, we can get its common denominator, or we're going to solve it, combine into one fraction. So we are going to have the common denominator of x times x squared plus 1, x times x squared plus 1 times x plus 1. It results to x squared plus 1 plus x squared plus 1 times x squared divided by x squared plus 1 times x is equal to x squared. Okay, so it results this combine x squared plus 1 plus x squared is equal to 2x squared plus 1 over x times x squared plus 1. So this is the final answer. So let's proceed with the number 21. We have here the number 21. Y is equal to e to the x minus e to the negative x over e to the x plus e to the negative x. By this problem, we will let this is our u and this is our v. And differentiating each, if we have here in getting the u prime derivative of u, it results to e to the x plus e to the negative x. We're going to get the derivative of this v, e to the x minus e to the negative x. So apply the quotient rule. So we have here the quotient rule, the derivative of u times v minus u, and the derivative of v over v squared. So we are going to copy it, e to the x plus e to the negative x squared minus the e to the x minus e to the negative x squared over e to the x plus e to the negative x squared. Okay, so we are going to use difference of squares. So we all know that the difference of squares is a plus b squared minus a minus b squared, so it equals to 4ab. So 4 times e to the x plus e to the negative x is 4. So it is 4 over, copy denominator, e to the x plus e to the negative x squared. So this is our final answer. So let's proceed with the number 22. Number 22 is, okay, so I have here the copy. 22, y is equal to 1 over 2 sine 2x. So we are going to rewrite it. Y is equal to 1/2 sine 2x to the negative 1. Apply the chain rule. 1/2, copy 1/2 times the negative 1 sine 2x to the negative 2. Then the derivative of sine 2x is 2 cos 2x. So after that, we are going to simplify it, and it results to negative cos 2x over sine squared 2x. pwede ni siya mo ni ang final answer. Pwede po na to i-use ang katong cosecant and cotangent. So, pwede ni siya po. Y prime is equal to negative C2x cotangent 2x. Pwede ni siyang answer. Pwede po ni siyang answer. So, that is our solution for number 22. So, let's proceed with the number 23. Number 23 is y is equal to e to the negative x cos 2x. Okay? So, by solving this number 23, we are going to use product rule. Okay? So, y prime is equal to copy e to the x, since if we are going to get the derivative of e to the negative x, it remains e to the negative x, copy cos 2x, plus the e to the negative x, the derivative of the cos 2x is 2 negative 2 sine 2x. So, we are going to bahigon sa nato. Bahigon sa nato. Okay, so e to the negative x cos 2x minus 2 e to the negative x sine 2x. We cannot solve more, so we are going to get its factorization with e to the negative x. Negative e to the negative x, so it results to e to the negative x times copy cos 2x plus 2 sine 2x. So this is our final answer. Number 24. Y is equal to secant squared root of x. Okay, so we are going to apply the chain rule, but before that, we will let this v be our x and 1/2, and our u is secant u tan u. Okay, so that is our derivative each of this. Okay, so apply its chain rule and multiply. So the result is 2 secant squared root of x times tan square root of x times 1/2 square root of x. So from that, we can simplify it. Y prime is equal to, okay, copy secant square root of x. So cancel it out first. So tan square root of x over square root of x. So this is our final answer. Number 25. We have here the problem x ln cube x. So in solving this problem, we are going to apply the product rule. Okay, so we have here y prime is equal to the derivative of x is 1 times the ln x3 plus derivative of the ln x is 1/2. Okay, so x times 3 ln x squared over x. Next, we are going to simplify it. This is equal to ln x cubed plus 3 ln x squared. Cancel this out. It results to this. So this is our final answer. Number 26. We have here y is equal to sine negative 1 x minus square root of 1 minus x squared. 26. So we are going to differentiate each term. In differentiating each term in sine to the negative 1x, it results to 1 over square root of 1 minus x squared. So y prime is equal to 1 over square root of 1 minus x squared, and the derivative of this 1 minus x squared is negative x over square root of 1 minus x squared. Okay, so by combining this, negative times negative is already positive. So 1 plus x over, copy this one, 1 minus x squared. So this is our final answer. Number 27. We have here the problem y is equal to 1 plus x squared over 1 minus x squared. Okay, apply its quotient rule. Okay, quotient rule, v du minus u dv over v squared, y prime is equal to, copy 1 minus x squared. So this is our u, v, this is our u, times derivative of x squared is 2x, minus copy 1 plus x squared, derivative of this is 2x, negative 2x, 1 plus negative 2x. So sim over 1 minus x squared to the second power. So simplify the numerator. It results to 2x. 2x minus 2x cubed plus 2x cubed minus or plus 2x, okay, over 1 minus x squared. So cancel this out. It remains 2x. 2x plus 2x equal to 4x over, copy 1 minus x squared to the second power. So let's proceed with our 28. So this is our final answer for 27. Number 28 is plus cos x plus y is equal to 0. By solving this number 28, we are going to differentiate it implicitly. Okay, so y prime or dy over dx, is equal to derivative of x is 1 plus derivative of cos is sine. Okay, negative sine x plus y times 1 plus y, dy over dx equal to 0. Okay, so we are going to move this from here. Okay, so 1 plus y dy over dx, and we are going to transfer this to the left side, 1 over sine x plus y. Okay, after that we are going to remain this y or dy over dx or dy prime equal to 1 over sine x plus y minus 1 from here. And by that, we can simply make this is our final answer, or we can simplify it more by using the cosecant x plus y minus 1. So this is our final answer. Number 29. 29 is x cubed minus xy plus y cubed is equal to 1. So we are going to differentiate it implicitly again. Okay. Okay, so we are going to get the derivative of x cubed, which is 3x squared, minus this y first, subtract y, plus x. The equivalent of this y is 1 times dy over dx, plus the derivative of y cubed is 3y squared dy over dx is equal to 0. So from this, we are going to bahigon it first. Okay, we are going to bahigon ang na dy over dx diri sa left side, ang katong wala dx squared minus y ato sa pikas. Okay, so x times 1 is x dy over dx plus 3y squared dy over dx is equal to negative 3x squared plus y. So, extract, divide both sides by x plus 3y squared. Put dy over dx here. Kani. So, our final answer is, okay, so get its factor nato ni siya. Pwede na siya mabutang out negative minus, kani siya, minus, negative 3x squared minus y. Pwede na ito na siya mainama. So, negative 3x squared minus y over the x plus 3y squared. So, this is our final answer. For number 30, we have here the problem y is equal to e to the x squared. So, in solving this number 30, use the chain rule, differentiate exponent. Okay? So, our final answer for this is equal to 2x e to the x to the squared. So, our final answer. For the number 31, okay, number 31, we have here, number 31. The problem is y is equal to tan x over 2x minus 3. Okay, so we are going to apply its quotient rule. Y prime is equal to 2x minus 3 times the derivative of tan x is secant squared x plus tan x times the derivative of 2x minus 3 is 2 over 2x minus 3 squared. So our final answer is equal to, distribute this, 2x minus 3 secant squared x plus 2 tan x over 2x minus 3 squared. So this is our final answer, number 31. So let's proceed with the number 32. Number 32, the problem is g of t is equal to t squared over t minus 11. Apply the quotient rule. So g prime t is equal to t minus 11 times the derivative of t squared is 2t minus t squared times the derivative of t is 1. So g prime t over t minus 11 squared. So t minus 11 times 2t is also 2t squared is equal to 20 minus 22t minus t squared over t minus 11 squared. So g prime t, combine the t squared and negative t squared, results to t squared minus 22t over t minus 11 squared. So this is our final answer, number 33. F of x is equal to x squared minus 4x plus 2 times 2x cubed minus x squared plus 4. So we are going to use its product rule again. Okay, so product rule, we have here f prime x. Get first the derivative 2x minus 4. Copy this one. Copy this. Okay, so 2x cubed minus x squared plus 4. After that, we are going to add, copy this one, x squared minus 4x plus 2, and get its derivative from this v. So 6x squared minus 2. Okay, 2x. So this is our final answer, number 34. Number 34, y is equal to secant 8x. So by solving this, we are going to use chain rule. Okay, so y prime is equal to secant 8x. The derivative of secant is secant and tan. So tan 8x, derivative of the 8x is 8. Okay, so y prime is equal to, okay, multiply this, put this 8 into the front, 8 second, 8x, copy, tan 8x. Okay, so this is our final answer. Number 35. Final answer for number 34. Number 35. Okay. By the way, number 35 is y is equal to 5 that x plus sine x. In solving this, we are going to get a differentiate term by term and simplify. So 5e to the 3x, it results to 15 e to the 3x plus derivative of sine x is cos. So this is our final answer. Number 36. We have here the problem y is equal to x squared minus a times 2/3. Apply the chain rule, 2 over 3 x squared minus 8. If we are going to subtract negative 2/3 minus 1, it results to negative 1/3 times 2x from this. Okay, so 2/3 times 2x, it results to 4x over 3, and since it is a negative exponent, so we're going to bring it down. So 4x 3 times x squared minus 8 1/3. So this is our final answer. Number 37. Have here f of x is equal to 5 over 2x minus 3 to the 4th power. So extract its exponent or rewrite it. Okay, so f of x is equal to 5 times 2x minus 3 to the negative 4 times 2. Okay, so f equal to 5 times negative 4 times 2x minus 3. Negative 4 minus 1 is 5 times 2. 5 times negative 4 times 2, it's negative 40. Negative 40, bring this down because it has a negative exponent. It's 3 to the 5th power. So this is our final answer. Number 38. We have here the problem. Okay. Number 38. G of x equal to x squared plus 5 over x squared plus 6x. So we are going to use the quotient rule. VDU minus UDV over V squared. So x squared plus 6x. Derivative of x squared plus 5 is 2x. Minus x squared plus 5. Derivative of this is 2x plus 6. After that, distributive property. X squared plus 6x times 2x is 2x cubed plus 12x squared minus 6x squared minus 2x third power plus 10x plus 30x over x squared plus 6x squared. Okay, so combine. We're going to cancel this out. So 12x squared minus squared is equal to 6x squared. Copy plus 10x plus 30x over x squared plus 6x squared. So this is our final answer. Number 39. Number 39. We have here the f of x is equal to negative 10x squared minus 3 over 4x plus 1. So apply its, what we call that one, the quotient rule. So 4x plus 1 times negative 20x minus negative 10x squared minus 3 times 4. Okay. Number 39. Okay, so we are going to simplify or distributive property. So it results for x plus 1 times negative 20x is negative 80x minus 20x, okay, plus 40x plus 12 over 4x plus 1 squared. So combine this, okay? So negative 80x squared plus 40 is equal to negative 40x squared minus copy 20x, okay, 20x plus 12 over 4x plus 1 squared. This is our final answer, okay, for number 13. Let's proceed with the number 40. We have here the y is equal to x cubed ln x. By solving this number 40, we are going to use the product rule. So y prime, the derivative of x cubed is 3x squared, copy ln x, plus x cubed, the derivative of ln x is 1 over x. Okay, so y prime is equal to 3x squared ln x plus, cancel this out, it remains x squared. This is our final answer. Number 41. We have here y is equal to square root of 4x plus 2. Y prime is equal to 4x plus 2 to the 1 half. Y prime is equal to 1 half times 4x plus 2, negative 1 half times 4. Okay, so y prime is equal to 1 half times 4 is 2 over, make this negative 1 half into positive and put it in the denominator, 4x plus 2, 1 half. You can simply write this as 2 over square root of 4x plus 2. Okay, so that is our final answer. Number 42. Sin x minus cos y minus 2 is equal to 0. By solving this number 42, we are going to differentiate it implicitly. So, sin, derivative of sin x is cos x minus derivative of sin. The cos is negative sin x is equal to 0. Since it is constant, it already 0. Okay? Okay, cos y I mean. Okay? So, we are going to add its dy over dx. So, copy minus, plus already negative times negative is plus sin y dy over dx equal to 0. So, put sin y here, sin y dy over dx is equal to, ibutang sa pikas ang negative cos x. Okay, so divide both sides by sin y. Sin y. Cancel, it remains dy over dx is equal to negative cos x over sin y. Cos x over sin. Okay, so for the number 43, we have here 3x squared is 2xy plus 5y squared is equal to 1. Okay, so we are going to implicitly or solve it implicit. It is an implicit differentiation. 3x squared is equal to 6x minus 2y plus 2x times 1 dy over dx, okay, plus 10y dy over dx is equal to 0. So, ibali na to ang walay dy over dx sa right side. And i-remain na to sa left side ang na dy over dx. So, minus negative times positive is equal to negative. So, negative 2x dy over dx plus 10y dy over dx is equal to negative 6x plus 2y. Okay, so divide both sides by negative 2x plus 10y. So, butang na to ang dy over dx here is equal to negative 6x plus 2y over negative 2x plus 10y. Since nasa like common, by 2, 3, may mo siyang 5. dy over dx, the correct answer would be 3x plus y over negative x plus 5. Our final answer. Our last number, 44, is our final answer for number 43. Number 44. X squared plus 2xy is equal to y squared. So get first its derivative x squared, 2x plus 2y plus 2 times y dy over dx is equal to 2y dy over dx. Okay? So, ibalhin na to ang dy over dx sa left side, 2x dy over dx. Make this a subtraction, 2y over dx is equal to negative 2x minus 2y. Divide both sides by 2x minus 2y. Put the dy over dx here. Cancelled out. So, negative 2x minus 2y over 2x minus 2y. Okay? So, by that, we can make this into common factor is negative. So, 2x minus 2y. 2x plus 2y over 2x 2y. So, na sila common tag 2, tag 2. So, dy over dx, the correct answer would be x plus y over x minus y. So, this is our final answer. Okay. That's all for my solution. That's all for my solutions. And I hope you learned something from this video. And thank you very much.